The risk committee met every quarter. They were diligent, too. They had a list, dozens of enterprise risks, each one with an owner, a rating, and a plan. Cybersecurity, supply chain, regulation, financial exposure, reputation. All the usual suspects. And here's the twist. AI wasn't on the list. Not because they weren't using it. They were using AI everywhere. Pricing, customer support, forecasting, internal productivity. But in their minds, AI wasn't a risk. It was a capability. A competitive edge. Something you do, not something that happens to you. Then the problems started showing up, one by one. A pricing system made thousands of decisions that added up to illegal discrimination. No one set out to discriminate. The model picked up patterns and ran with them. A customer-facing assistant gave confident, completely wrong guidance about a safety recall. A key vendor updated a model with basically no warning, and workflows that had been stable for months started acting weird overnight. And someone, trying to move fast, pasted confidential information into a public AI tool, and that data effectively walked out the door. None of those incidents were on the risk register. And yet every single one of them was an AI risk. Put together, they exposed the blind spot. The company rolled out AI faster than it learned how to manage the downside. All season, we've taken AI risks one at a time. Hallucinations. Bias. The way human judgment can quietly get outsourced. Privacy. But in real organizations, these don't arrive politely, one at a time. They hit you all at once, interacting and compounding, because AI isn't one project anymore. It's spread across the business. So today, we're going to stitch it all together. Not to scare ourselves with a big catalog of fears, but to build something usable. A systematic map of the AI risk landscape, so you can identify risk, assess it, reduce it, and still capture the value. I'm Nakel Nakima, and this is the Intelligence Edge. Joining me is a 4-guest panel with different perspectives on the same problem: how to make AI value sustainable by managing the ways it can go wrong. Dr. Lian Zhou is an AI transformation leader who's worked with organizations trying to get the upside of AI without stepping on a landmine. Welcome back.
Thanks, Nakel. I love this topic because it's the difference between AI as a quick win and AI as something you can actually depend on for the long run.
Maria Alvarez is a data governance leader, and if anyone can tell us where risk management becomes real and repeatable, it's someone who lives in governance. Maria, great to have you.
Happy to be here. I'll say it up front, if you don't have governance, what you have isn't risk management. It's just stress.
Jonas Richter is our data ethics and compliance specialist, the voice that keeps us anchored on the consequences that actually land on human beings. Jonas, welcome.
Thanks, Nakel. It's simple to say and harder to practice, but the risks that deserve the most attention are the ones that hurt people.
And Kwame Mensah is an intelligence systems architect who builds safeguards into real systems, not just policies in slide decks. Kwame, good to have you.
Always a pleasure. If the controls aren't engineered, they don't exist. That's my bias.
Let's start broad. Before we talk solutions, we need a map. Dr. Zhou, if you had to give leaders a clean way to organize AI risk, what are the major buckets?
I usually break it into 5 categories, because otherwise the topic becomes unmanageably large. First is performance risk, meaning the model is wrong. It's inaccurate, unreliable, it degrades, it makes things up. Second is fairness and ethical risk, meaning the system causes harm to people. Bias and discrimination, privacy violations, manipulation, unfair treatment. Third is security risk. The AI system gets attacked, hijacked, or misused. Think adversarial inputs, prompt injection, data exposure, or someone using it as a tool for wrongdoing. Fourth is operational risk, which is basically dependency. You build processes that rely on AI, and now AI failure becomes business failure. Vendor changes, fragile workflows, human skills fading away. And fifth is strategic and societal risk. Big picture consequences, reputational damage, regulatory blowback, competitive disruption, broader societal effects. Those are the 5: performance, fairness, security, operational, and strategic.
And what's interesting is our cold open hits multiple categories without trying. Discriminatory pricing is fairness. Wrong recall guidance is performance. Vendor model shift is operational. Confidential data leaking is security. Kwame, I want to poke at something. A lot of leaders hear this and think, okay, risk is risk, we already manage technology risk. Why does AI need a different approach?
Because AI behaves differently from traditional software in ways that break the old playbook. First, non-determinism. With classic code, if you input A, you get output B, every time. With AI, you can get variation. You can't test every possible behavior the way you test a deterministic system. Second, opacity. In traditional systems, you can inspect the logic. In ML systems, especially complex ones, you often can't fully explain why you got a specific output. That changes how you do assurance. Third, emergence. Some failure modes aren't explicitly designed in. They show up because the model learned something unintended. That discriminatory pricing example is classic. Nobody coded discrimination, but the system found proxies and optimized the wrong thing. Fourth, drift. The world changes, data changes, vendors update models, retraining happens. So something that passed validation 6 months ago might be unsafe today. And fifth, scale and speed. A single biased person makes a limited number of decisions. A biased model can hit millions of people in minutes. So the blast radius is different.
Right, so even if your governance is solid for normal systems, AI adds unpredictability, hidden reasoning, and this constant motion problem. Maria, bring us back to the foundation. Where does data governance sit in all this?
Honestly, a huge portion of AI risk is data risk wearing a new outfit. If the data is messy, performance will be messy. If the data encodes bias, the model will reproduce it. If you don't control sensitive data flows, you get security breaches. And then there's the governance part, ownership, standards, lineage, definitions. If you don't know where data came from, who's accountable, and what good looks like, you're basically building AI on sand. But I'll add a nuance: data governance alone doesn't solve it. You also need model governance, deployment governance, and ongoing monitoring. Still, if your data governance is immature, AI risk multiplies fast.
Jonas, when you look at a risk framework, what do you want to see at the center? What should anchor it?
The question I keep forcing teams to answer is, who gets harmed if this goes wrong? Frameworks often drift into abstractions. Accuracy metrics, uptime, cost. Those matter, but they're not the moral center. So I anchor it in human impact. First, identify the affected people, not just the affected business unit. Customers, employees, communities, patients, applicants, whoever is in the blast radius. Second, make the harms concrete. Discrimination, exploitation, safety risks, privacy exposure. Real outcomes. Third, prioritize by severity and likelihood. And fourth, mitigate with the goal of preventing harm, not simply preventing bad headlines.
Okay. Let's zoom in. Segment 2, Performance and Security. Kwame, performance risk sounds straightforward until you're living it. What does it look like in practice, and what do you do about it?
Performance risk is basically the model being wrong, but wrong comes in flavors. Inaccuracy is the obvious one. You validate against ground truth, track outcomes, and monitor the accuracy over time. Then hallucination, especially with generative AI, where the system produces plausible nonsense. You mitigate that by grounding in trusted sources, checking citations, putting humans in the loop for anything consequential, and building a verification culture where people don't treat the output as truth by default. Another one is calibration. Sometimes the system is way too confident for how often it's right. You need calibration testing and you need to present uncertainty honestly. Novel situation failure is huge. The model sees something out of distribution and just guesses. That's where monitoring, escalation paths, and preserved human expertise matter. And drift, over time, the model can degrade. So the core principle is continuous verification. With traditional code, you ship it and it stays the same. With AI, you assume it can change and you keep checking.
Dr. Zhou, organizations get stuck on the word accuracy. They want a single number, a threshold, a pass/fail. How should they think about what's good enough?
Good enough depends on context. A model that's 95% accurate might be amazing in a low-stakes recommendation engine and totally unacceptable in a high-stakes setting like diagnosis or safety-critical decisions. Also, don't compare to perfection. Compare to what you do without AI. If humans are currently at 90% and the model is at 95%, that's an improvement, even though it's not flawless. And leaders often miss the distribution of errors. Not all mistakes are equal. If the 5% failure cases cluster around the most vulnerable customers or the most critical scenarios, that's a very different risk than random minor errors. So the right move is, set performance requirements based on the stakes, understand when errors happen, and put safeguards where they matter most. Don't demand perfection where it's unnecessary, and don't accept mediocrity where the consequences are severe.
Let's go to security. Kwame, this is where people realize AI isn't just a product feature. It can be an attack surface.
Exactly. You've got adversarial attacks, where inputs are crafted to fool the model. You deal with that via adversarial testing, stronger validation, and robustness techniques. Data poisoning is another, messing with training data so the model is compromised from the inside. That's why provenance, data governance, and anomaly detection for training sets matter. Model extraction and theft, attackers trying to replicate your model or steal its capabilities. You need access control, monitoring, rate limits, and IP protection. With Gen AI, prompt injection becomes its own category. Someone writes an input that overrides your instructions, pulls out private info, or makes the model behave dangerously. Mitigation includes input handling, instruction hierarchy protections, and output filtering. And then there's data leakage, the everyday version. Employees dropping sensitive information into tools that aren't approved. That's not theoretical. It's happening everywhere.
Maria, that last one is so common. People are trying to be productive. How do you govern it without just yelling, "Don't do that"?
You need layers, because prohibition alone creates shadow behavior. First layer is policy, really clear rules. What data is allowed and what tools. Not vague, not buried in a PDF. Second layer is providing approved tools. If you want people to stop using random public services, give them a safe alternative that meets security and compliance requirements. Third, technical controls, data loss prevention, access restrictions, monitoring. If you can prevent sensitive data from leaving in the first place, you should. Fourth is education. Many employees genuinely don't understand what happens to prompts and uploads, or that the data might be retained and reused. And fifth is monitoring and follow-through. You watch for violations, you correct behavior, you improve controls. The goal is to channel AI use safely, not pretend you can eliminate it.
Segment 3, Operational Risk, the Dependency Story. Dr. Zhou, when AI becomes part of operations, what new fragilities show up?
Dependency is the big theme. If AI drives a critical workflow, AI failure becomes operational failure. That's the simplest form. Vendor dependency is massive too. Many companies rely on external models and platforms. If the vendor updates the model, changes pricing, changes terms, or goes down, you inherit that risk immediately. That cold open example, the model changing overnight, that's a real operational shock. Then skill atrophy. When AI handles tasks, people stop practicing. Over time, the organization loses the ability to do the work without AI. And over-reliance, sometimes called automation bias, where humans defer to the system beyond what's justified. Finally, there's complexity, multiple AI systems interacting, edge cases cascading, behavior becoming harder to predict.
Kwame, how do you design an organization that benefits from AI but doesn't collapse if it has a bad day?
You design for failure as a normal condition, not as an exception. 1. Fallbacks. Keep manual processes or backup systems for critical functions. It costs money, but it's insurance. 2. Graceful degradation. If the AI component fails, the system should lose features, not implode. Partial function beats total outage. 3. Vendor risk management. Avoid a single point of failure. Maintain alternatives. Know what happens if the vendor changes models. Negotiate contract protections. 4. Skill preservation. Keep humans capable. Training, periodic manual runs, making sure expertise doesn't disappear. 5. Monitoring and alerting so you catch degradation early. And 6. Circuit breakers. A way to shut the AI off or constrain it when it starts doing harm. The principle is simple: build for AI failure, not just AI success.
Maria, from the governance view, how do you keep dependency from becoming accidental and dangerous?
You govern concentration and continuity. First, you measure how dependent you are on any single AI system or vendor. If dependency is concentrated and critical, that's a red flag. Second, you require resilience proportional to criticality. If an AI system is mission-critical, you demand fallbacks, redundancy, and continuity plans. Third, vendor governance, stability assessment, alternatives, contract terms, exit plans. Fourth, business continuity planning that explicitly includes AI failure scenarios, not as an afterthought. And fifth, skill governance. You identify which human capabilities must remain strong and you actively maintain them. Otherwise, you wake up one day and realize the organization can't function without the tool.
Jonas, is there an ethical layer to dependency? Or is it just an engineering and operational story?
There's absolutely an ethical layer. First, responsibility doesn't disappear because a vendor built the model or because the workflow is automated. The AI did it is not an ethical defense. Second, when AI-dependent services fail, the people harmed may be the most vulnerable. Think healthcare, public benefits, critical infrastructure. Resilience is not only a business concern. It's a duty to those who depend on what you provide. Third, dekilling affects human dignity. When jobs are hollowed out and judgment is removed, workers lose competence, identity, and leverage. That's not just inconvenient, it's harmful. And then, at societal scale, dependency becomes systemic risk. If entire sectors rely on AI systems that can drift, be attacked, or fail, we're creating fragility beyond any single firm.
Segment 4, we've got the categories, we've got examples, now we need an integrated framework. Dr. Zhou, if you were advising a company that wants to do this systematically, what cycle do you put in place?
I use a 5-stage cycle that borrows from classic risk management, but fits AI's quirks. Stage 1 is identify. You systematically surface AI risks across all 5 categories, for every AI system you have. The cold open organization failed right there. If AI isn't even in your risk identification process, everything else is moot. Stage 2 is assess. You rank risks by likelihood and impact, and this is where human impact needs to be explicit, not implied. Stage 3 is mitigate. You apply controls proportionate to risk, and those controls can be technical, procedural, and governance-based. Stage 4 is monitor, continuously. Because AI drifts, and new failure modes emerge. You don't do one risk assessment and call it done. And stage 5 is respond. Incidents happen. The question is whether you detect them quickly, contain harm, remediate, and then feed learning back into the process. Identify, assess, mitigate, monitor, respond. Then repeat.
Kwame, for that cycle to function, you need real plumbing. What are the technical building blocks?
First, an AI inventory. You cannot manage what you can't see. Most organizations don't have a complete list of where AI is deployed, what it does, and who owns it. Second, consistent risk assessment tooling. Not everyone reinventing the questionnaire. Standard triage and assessment methods so judgments are comparable. Third, monitoring infrastructure, performance, drift, bias signals, security anomalies. As much automation as you can, because manual monitoring doesn't scale. Fourth, incident management customized for AI. Detection, escalation routes, containment tactics, post-incident review. You want it integrated with broader incident response, but with AI-specific analysis. Fifth, governance integration. The tech controls need to connect to enterprise risk management, compliance, and leadership reporting. Otherwise it becomes a silo. Without infrastructure, policy is just aspiration.
Maria, take that integration point. How do you connect AI risk to enterprise risk management so it's not a side project?
The first move is embarrassingly practical. AI risks must appear on the enterprise risk register. Owned, rated, tracked, reviewed. If it's not there, it's not being managed at the enterprise level. Second, align the methodology. Use the same rating scales, the same cadence, the same reporting rhythm, so AI risk can be compared against other risks in a coherent way. Third, name owners. Not the data team as a vague concept. A person. Clear accountability. Fourth, board visibility for major AI risks. If AI is material, leadership oversight needs to match that. And fifth, coordinated incident response. AI incidents often trigger reputational and regulatory impacts, not just technical fixes. So the response cannot be isolated in engineering.
Jonas, you've been saying, don't let this become a purely organizational self-protection exercise. How do you bake human impact into each stage of the framework?
In identification, you explicitly list human harm scenarios, not only technical failures. You ask who could be harmed and how. In assessment, you weight human impact heavily. A risk that could seriously hurt people should be prioritized even if the financial impact seems modest. In mitigation, you direct resources toward preventing discrimination, protecting privacy, and ensuring safety, not just toward preventing downtime. In monitoring, you monitor for harm signals. Is the model treating groups differently over time? Are privacy boundaries being crossed? Are safety errors emerging? And in response, if people are harmed, remediation includes them. Not only internal cleanup. That's how you prevent the failure mode where the company protects itself while leaving damage behind.
Segment 5, Culture. Because a risk framework can look perfect and still fail if people are afraid to raise concerns or everyone is rewarded only for speed. Dr. Zhou, what does a risk-aware AI culture feel like inside an organization?
It feels like balanced energy. People are excited about AI, but not naive. I call it realistic optimism. You're not allergic to AI, and you're not intoxicated by it. It also has psychological safety. If an engineer sees bias, or a frontline user sees repeated errors, they can say it without feeling like they're slowing the company down or making themselves a target. There's also a habit of balancing value and risk in actual decisions. Not after the fact. And when incidents happen, the tone is learning, not blame, because blame cultures hide problems. Finally, it's shared responsibility. AI risk isn't only the job of a risk team. Developers, managers, users, leaders, everyone has a piece of it.
Maria, you said earlier governance isn't just rules, it shapes behavior. How do you use governance to create that culture instead of killing it with bureaucracy?
Governance shapes culture through signals. 1. Measure what matters. If you track AI risk, review it, and report it, people understand it's real. If you never measure it, they assume it's optional. 2. Reward the right things. If promotions and praise go only to the teams that ship fastest, you'll get reckless deployment. If you recognize people who catch risks early, you build vigilance. 3. Embed requirements in the workflow, risk assessments, approvals, monitoring plans. Not as punishment, but as normal professional practice. 4. Leaders have to model it. If leaders visibly take risks seriously, everyone else follows. And 5. Protect people who raise concerns. If reporting risk gets you labeled difficult, your governance program will be fiction.
Jonas, where does leadership show up here? What do leaders do that makes the difference?
Leaders set the risk appetite whether they admit it or not. Their decisions teach the organization what corners are acceptable to cut. They also model balance. If leadership is all hype and no caution, people learn to suppress concerns. If leadership is thoughtful, excited but careful, that becomes the norm. They must protect truth-tellers. The people who point out uncomfortable risks are doing the organization a favor. If they get punished, you lose visibility until the incident becomes public. And leaders have to resist pressure. There is always pressure to deploy faster, to skip governance, to treat risk as a tax. Responsible leadership is sometimes saying, no, we're not shipping that yet. Finally, they own outcomes. If AI harms people, leadership can't outsource accountability to a model, a vendor, or a junior team.
Segment 6, Our Tactical Edge. I want listeners to leave with actions they can take this week, not someday. Dr. Zhou, what's the first move?
Open your enterprise risk register and check whether AI is on it in a real way. Not a vague line item, but specific AI risks identified, assessed, and owned. If AI isn't there, you have the exact blind spot from the cold open.
Maria, your one move.
Build or validate your AI inventory. Can you answer, with confidence, what AI systems are deployed, where they're used, what data they touch, and who's accountable? If you can't, you're managing unknown risk.
Jonas, what's your tactical question?
Pick your highest stakes AI system and ask, who could be harmed, exactly how, and what are we doing to prevent those specific harms? If the conversation stays inside the organization's walls, you've found the gap.
Kwame, bring us home.
Choose one critical AI dependency and run a resilience test. If it failed tomorrow, what breaks? Do you have a fallback? Can you degrade gracefully? Is there a circuit breaker? If you don't have an answer, you just found a priority vulnerability.
Let me synthesize what we built today. AI risk is not one problem. It's a landscape, and it fits into 5 major categories: performance risk, meaning the AI is wrong; fairness and ethical risk, meaning people get harmed; security risk, meaning the system is attacked, manipulated, or leaks data; operational risk, meaning you become dependent and fragile; and strategic and societal risk, meaning the broader consequences hit your reputation, your regulatory exposure, your competitive position, and beyond. AI requires its own risk discipline because it's probabilistic, often hard to interpret, capable of unintended behaviors, prone to drift, and amplified by scale and speed. So the classic, test it once and ship it, mindset doesn't work. You're in continuous verification territory. We also talked about the operational reality. The same dependency that creates value also creates vulnerability. Resilience means fallbacks, graceful degradation, vendor management, skill preservation, monitoring, and circuit breakers. You design assuming failure will happen, and you make sure failure is survivable. And we pulled it into a single management cycle: identify, assess, mitigate, monitor, respond. supported by real infrastructure like inventories and monitoring. Integrated into enterprise risk management so it's visible, owned, and governed. And anchored in human impact, so risk management doesn't become a corporate self-defense exercise that forgets the people affected. Finally, culture and leadership are what make all of this real. A risk-aware culture is optimistic but clear-eyed, safe for raising concerns, focused on learning, and built on shared responsibility. Leaders set the appetite, protect the truth-tellers, and own the outcomes. And here's the big takeaway: risk management isn't what slows AI down. It's what keeps AI valuable over time. To our panelists, Dr. Lien Zhou, Maria Alvarez, Jonas Richter, and Kwame Mensah, thank you for pulling all of this together.
Thanks, Nakel. This is the kind of conversation that prevents regret later.
Great discussion. If people take only one thing, I hope it's that management has to be systematic.
And human-centered. That's the missing piece in a lot of frameworks.
And engineered. If it isn't built into the system, it won't hold up under pressure.
Next week on The Intelligence Edge, we're shifting to the other side of the equation, AI ROI, and how leaders prove the value of machine intelligence. Until then, I'm Nakel Nikima. Make better decisions.